Hello guys, welcome to back to my channel. Today's our topic is probability distribution. Contents: introduction based on probability, examples of probability, probability distribution, formula based on probability distribution, problem based on probability distribution, types of probability distribution, binomial distribution, Poisson distribution, real-time example for probability distribution, random example, types of random variables, and conclusions. Introduction. The probability of the events E is given by P of E is equal to M by N, where P of E is the probability of an event and M is the number of favorable outcomes. N is the total number of events in the sample space. Probability of a non-happening event is P of E is equal to 1 minus M by N. Hence, P of E is equal to 1 minus P of E. The theorem of probability addition, theorem of probability multiplication, or probability or product theorem of probability. When a card drawn from a packet of 52 cards, find the probability of getting of sub-question A, king or queen. Solution: number of possible outcomes n is equal to 52 and number of favorable outcomes m is equal to 4. Probability of getting king p is equal to m by n. M value is 4 and n value is 52. Number of favorable outcomes m is equal to p plus p, king plus queen, is equal to 4 plus 4 is equal to 8. Therefore, m becomes 8 and n as we know that n is 52 possible outcomes and favorable outcomes is 4. 4 plus 4 is 8. Okay, then we know the formula p is equal to m by n. M value we had obtained 4 plus 4 is 8 and n value, as we know, the number of possible outcomes is 52. So 8 by 52 is 2 by 13. Okay. Next, probability distribution of a random variable shows how the probabilities of the events are distributed for different values of the random variable. When all values of the random variable are aligned on a graph, the values of the probabilities generate a shape. The probability distribution has several properties that can be measured. It should be kept in mind that the probability of a favorable outcome is always greater than 0 and the sum of all the probabilities of the events is equal to 1. Some formula on probability distribution. Mean is summation of x into p of x, and variance, so summation is equal to x minus mu whole square by p of x. Standard deviation, summation of x minus mu whole square of p of x, root to the power to the root whole square. If for each value xi of a discrete random variable x being assigned a real number p of xi such that p of xi is greater than or equal to 0 and summation of p of xi is equal to 1, then the function of p of x is called the probability function. Therefore, the set of values xi p of xi is called a discrete probability distribution of discrete random variable x. The function p of x is called as a probability density function. Next, problems on probability distribution. Find the probability distribution of a random variable x in the given below. Find the value of k and the mean and variance of x. X value is 1, 2, 3, 4, 5 and p of x is equal to xi is equal to k, 2k, 3k, 4k and 5k. Okay, is summation, as we know that we have to calculate the x into p first, and 1 into k is k, and 2 into 2k is 4k, and 3 into 3k is 9k, and 3 into 4 into 4k is 16k, and 5 into 5k is 25k. And the summation of xp is equal to it's 1k and 4k, 9k and 16k and 25k. Its total is 151. And okay, no, it's 55. And we have to calculate the x square into p. So 1 into k and 2 into 2 to the power 2 is 4 into 4k 8. And as it is same as the, if we have to calculate the cube root of it, a square of it, 27k, 64k and 25k, and its summation is 225. Okay, as we know, the p of x is equal to 1, and we have got the k value as 151. Thus the value of k is 151 of the given value of the data is 3.66, and the variance of the data is 1.6. Hence the mean and variance of the given data is 3.6 respectively. Okay, we have to calculate, we have to substitute the 1.6 into that value. We'll get the absolute given value of that equation. Okay, we had obtained the mean value as 3.66, and the variance as of the given data is 1.66. Hence the mean and variance of the data is mean is 3.66 and variance is 1.66 respectively. Types of probability distribution: normal distribution, uniform distribution, binomial distribution, Poisson distribution, and exponential distribution. Okay, normal distribution can be a normal, and binomial is a pyramid-like structure. Poisson's is like a bar graph, and the exponential is a line chart, and this also like a bar chart. Next, Poisson distribution. Poisson distribution is a discrete probability distribution, meaning that the given probability of a discrete outcome. For a probability distribution, discrete outcome is the number of times an event occurs, represented by k. You can use a Poisson distribution to predict or explain the number of events occurring within a given interval of time or space. Events could be anything from disease cases to customer purchase to meteorics. The interval can be specific amount of time or space, such as 10 days or 5 days square inches. P of x is equal to m power x e power m into x factorial. This is the formula to calculate the Poisson distribution formula. Real-time examples. Probability distributions are used in many sectors. Here is some of the examples where the concept of probability distributions are used in real time. To describe the population of real-time variables, test scores in a class or a standardized test weight of adult individuals in a population, blood pressure in population, internet downloaded speed, birth weight of a newborn babies, finding the success or failures, batting average in baseball, and etc. Random variables. If a random variable x is associated with the outcome of a random experiment, then x is called a Sankovic variant, and variable is variable. Sample space of the experiment is represented by a real number. Random variable is usually denoted by x, y, and z, and it may be denoted that the different random variables may be associated with the random space S and the set of real number of random variable. X is range of x. Suppose a coin is tossed twice on some of the random variables can be defined as x, y, z. Number of heads of outcomes, number of tails of outcomes, tails in outcomes, number of consecutive head. Find the random experiment of this solution. X first number of outcomes. head outcomes. So there is a two possibilities, one HH and HT and HTH. Hence the random experiment is R of 1 to T 0 1 2, and the outcomes okay, hence the random experiment has three outcomes. Okay, types of random variables. Discrete random, there are two types of random variables, discrete and continuous random variables. Discrete random variable can also take a finite number of values. To further understand this, let's see some of these discrete random variables. X is here. X is only take the values of 2, 4, 3, 3, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And X is the number of heads in 100 coin tosses. X can take only integer values from 0 to 100. Continue take infinite values in a continuous term, and let's see an example. Suppose we have to take a dot value which in which the dot the dot where the dot can fall anywhere, okay, between -1 to 1 and the x-axis. So define the random variable and the coordinate of the position -1 to 1 and infinite to mean possible values. Conclusion: the probability distribution is a crucial elemental concept in a probability. You are now familiar with the name and shape of the common probability distribution. You have found the structure and type of probability distribution vary according to the features of random variable distributions like discrete or continuous. Thank you.